reason.
Okay.
Will that be a little more stable?
Here, I want to make sure. See though.
Oh, I see. I see. Yeah.
Right. Let me check that.
Check it. Oh, you can't see it once you do that, can you?
No. So the video behind it, but whenever I start it, I think it's fine.
Does it look good right there?
Yeah, I think that's good. It doesn't need. It really just needs to hear me
You want to come out?
because it's at the bottom, so it has to tilt a little bit. I think it's fine. But when I do it, so we'll pick it up and follow me around. That'd be great.
Sure, I will.
Are you ready?
She's still, yeah, she's here. Yep, good, go. Yeah, you just gonna, you know, this one, you know. After the debrief, she's gonna debrief with us, but go into research maybe. So.
All right. Thank you guys for being patient. I know that took a minute to get everybody situated, but we're ready to start. Are you ready to roll? Awesome. Okay, so what I need are your hands in your lap. Remember, your notebooks can be put away. Your pencils can be on your desk. We don't need your notebooks out. You have your little sheet of paper that you're going to write on. You don't need your notebook. We're going to start this morning with a number six routine before we start our lesson, okay? So I want you to look at this model that's on the board. Are you taking this in? This says, look at this model that a student used to solve 300 minus 167. That's what they did, 300 minus 167. I want you to think about what this student did to solve the problem and why they did it. So take a look at what we have here. What happened? What does these mean? Everybody take it all in. What did they do? What's the answer? Now I want you to turn and talk to that partner that you see, your shoulder partner, and I want you to talk about what did this person do to solve the problem and why did they choose to do that? You ready? Turn and talk. They took one of their masks off. So they're taking this one off. I want y'all to think about why are they moving that one down? So what did they do to the 300? Okay, let's come back together. So let's talk about what's happening up here. I may need to pull this up a little right on the board. So let's talk about, who can talk to me about what's happening in this first of all, and then why is it happening? Who wants to share something you and your partners talked about what's happening in that? Yes, ma'am.
I think like they subtracted and then added it.
They did what?
Like they subtracted and then added it.
They subtracted and then added it. So talk to me more about that. What do you mean? Where did they subtract?
Like on the left side of it, it shows 166, the 167. You can tell that they added, and then on the other side it went down 299.
So try to tell your partner what's happening here with these two little loops in this one. Try to tell your partner what happened right here. we're doing both those numbers. Yeah. They took away one. Y'all see that? So we took, remember what problem we're solving, right? 300 minus 167, right? 300 minus 167. That's the problem we're solving. They shifted both of these, and now what are they at now? 166 and 299. So now we have a new problem, right? Y'all see that? I need you to talk one more time to your partner. Why did they choose to shift these one spot on the number line? I want you to talk about why they did that and what's the answer. What did they choose to do that?
It was easier to add it to get and then do 10 different ones.
They made it easier. What made it easier? Right. So they made it more efficient. But what's difficult about it when it's 300? What makes it difficult when it's 300? To do all that regrouping. Yeah, for sure. Okay, let's come back together. So why did they do that and what's the answer? You guys want to share kind of what you were saying? You want to share? Go ahead.
So, I think it's because
It's easier to have the answer. Did some of y'all talking about that in your group? You said it was more efficient. What makes it more efficient though? What makes it easier? How is this subtraction easier than this subtraction? Yeah, in the back. What? Say that louder. You wouldn't have to what? Regroup. Y'all like to regroup?
Yeah.
No, because then we've got to do all this. Like, okay, then I had to take the 300, became a 200, and that I traded out 100 for 10 10. So then that became 10 10. Then I traded out the 2 10s for 10 1. And oh my goodness gracious, it's a lot of work, right? So they just shifted it over, and then look, what's the answer? 133, right? The distance didn't change, did it? The distance between these two numbers is the same as the distance between these two numbers. So they just shifted them on a number line. That's some good thinking, don't you think? Yeah, so we're going to see if today, when we work on our lesson for today, if some of this thinking you might use it in your lesson today when you're working on your fraction, your mixed number problem. Are you ready? Okay, let's look at our problem for today. Our learning target, what we're learning today, is to solve problems involving mixed numbers. Y'all been doing that, right? I was in here the other day and you were working with mixed numbers. You're going to know when you have learned it when you can model the action of the problem and write an equation to solve. So you're going to model, you have some manipulatives that you might use, okay? And you also have paper where you can draw, and a lot of you use your number lines and things like that. But you have to also write an equation, okay? So you have to model and you have to write an equation. Ready to roll? Okay, let's look at our problem for today. So, you can flip your little sheet over because this same problem is on your little sheet. Ella has ordered 6 pizzas for a party. There are 2 3/4 pizzas left after the party's over. You guys like pizzas? Yeah, pizza parties are fun, aren't they? And so she has ordered 6. And how many are left? Tell your partner how many are left. Oh, are you talking to the party? 2 3/4 are left, right? It says there are 2 3/4 pizzas left at the party. What we want to know is how many were eaten. So that's what we're trying to figure out. But look what you're doing. With your partner, you want to model the problem, either on your paper by drawing or with the manipulatives. And you're going to write an equation to match the model. So whatever happens in your model, your equation needs to look like that, okay? You're finished, like you and your partner are done before I get to you. Guess what? If you're finished with both of these things, try it another way. We all know, I know Ms. Denton has been talking to you about there's lots of ways to solve the problem, right? So if you come up with one way, try another one with your partner. But I'm going to be coming by and asking you questions about what you're doing and what you're thinking. And remember our number sense routine and what our friend chose to do to solve that problem. I wonder if that's something that we might be able to apply here. Are you ready? Any questions? All right, I'm going to start my timer and you guys can start working with your partner. Go ahead and start talking about how to solve the problem. Yes, sir. You just stop here, didn't you?
So let's go ahead and you guys be partners and you guys be partners, okay? And y'all talk about how you can solve the problem. So talk to me about what you know in the problem. What do you know? She had 2 and 3/4 left. How many did she have to start with? 6. How would you show that with hands? How would you show me the 6 pieces with these? What would be your whole piece? What do you think? Those? Okay, can you show me the 6 pieces? How many whole pieces do they have? 6. So you have 1, 2, 3, 4, 5, 6. So there's your 6. How many are left now that the part is done? Oh, you think that? So I want you and your partner to work on how could you figure out how to find out how much was eaten with these. You have your 6 pieces. I want you and your partner to talk about if you have 2 and 3/4 left, how are you going to figure out how much was eaten? Okay? And then think about what an equation is like for that. Okay? All right. Oh, look at this. Talk to me about what you're thinking. Okay, tell me why you chose to start at 2 and 3/4. Okay, so you got 3. How did she get to 3? Did you do the same thing? Why did y'all choose to add 1 4? Okay, so you're getting to 3. What are you trying to end up on? I notice you're keeping going. Where are you going to end? You're going to end at 6. Why 6? There's 6 pieces. So once you finish your number line, how are you going to figure out what your answer is? Add all those together. Is that what you were thinking too? So this is going to be your difference. So that's how many pizzas will be left. I like this model. Here's what I'm wondering. Remember, on our success criteria, we want to think about an equation that would match that. I wonder what that would look like. And then when y'all finish your equation, is there another number line that you could draw besides this one? Remember that number line from the beginning in our number sense routine where they kind of moved both the numbers back? I wonder if you could do that. So I want y'all to talk about that and I'm gonna come back and check on you, okay? Okay. All right, talk to me about what you got going on over here. What does this represent? Tell me what you were doing. You had 6. So what was the 6 representing? 6 what? 6 groups, but in the problem, 6 was 6 what?
6 pieces.
6 pieces. So you have your 6 pieces, and then talk to me about what happened next.
We took away 2 and 3/4.
So I see your 2, and I see your 3/4. Where did the 3/4 come from? Right there. So I see this. I see what you did. You said I took away 2, right? And then you said I took away 3/4. What I'm wondering is, where did this 3/4 come from? So you knew you had to take away 3/4, but let's look over here. So you told me here was your 6 whole, and I love your action, right? You said I took away the 2. Now I need to take away 3/4. Can you pull 3/4 out of this? Look at your 4 pizzas that are left. Can you give me 3/4? Oh, so let me ask you a question. You put that 3/4 over here, but if you're going to take one of the holes off, how many of these do you need to put back? We're going to do a fair trade. Why is he getting another 4th out of this bag? Why is he doing that? What do you think? He did a fair trade, right? He went to the bank and he said, you know what? I'm going to need to fair trade those out, right? So now you've taken away 2 and you've traded out, regrouped the 1 whole for 4/4. Now what do you need to take away? Now, can you take away your 3/4 you were trying to take away earlier? Do it. Let's see it. Ta-da. So how many pizzas were left? Remember, you took these away. We ate, or no, these were left. I'm sorry, I asked the wrong question. How many were eaten? 3, and don't forget your other piece. 1, 4. So you see what you did. I love your thinking and how you decided to regroup that. Here's what I'm wondering. Okay, so you wrote 6, and then you got 4. How did you get 4 again when you first did that? You took away what? 2. So in your equation, can you make your equation match what happened here? So you took away the 2. What was left? Then what did you change? Then what did you take away? I want you to rethink those steps we just went through and show that in an equation to match our success criteria. Okay? Then I'll come back and check on you. Y'all work on your equation. I'll be back. All right, Fred, what is happening over here? Talk to me about your thinking.
So,
You drew 6 holes. Why did you choose to draw 6 holes?
because
There are 6 pieces. So then what happened? Okay.
You have to decompose it into because subtraction is that when you don't have any 4.
Oh, did y'all hear what he said? That he had to decompose this one into 4 fourths because he didn't have any fourths, so he regrouped.
The denominator is 4.
Yeah, so he had to decompose, and then he was able to take off those last 3 fourths and left you with 3 and 1 fourth. Is that what I hear? That is excellent thinking. Here's what I'm wondering. Remember our first, and you have an equation. Oh my gosh, it's beautiful. So here's what I'm wondering. Remember that number sense routine we did at the beginning of the lesson, where they started with those numbers on a number line? Could you see if you could apply that to this problem? And remember, we wanted to try to solve it a different way. So could we draw a line, and where would the 6 and where would the 2 and 3 fourths go on that line? And then could you do that same thing that our person did on number sense routine? That's what I want y'all to think about, and I'll come back and check on you, okay? Think about what that number line would look like and how you could shift it, okay? All right, I'll be back. All right, ladies, what's happening back here?
I see your model.
6 holes.
So you can add 1 4 like I did.
Okay, so she said she made one of these. Can you do that again? What you just did? You had these 6, and you said you made one of these. Okay, why is she making one of these with these fourths?
Because you can't cut these into
That's right, they're all stuck together, right? So you kind of had to trade them out. So did you trade them out first? So show me your action again. So tell me what, once you got your hole made, they're hard to put together, aren't they, to make a hexagon? So once you got that traded out, then what did you remove and why?
So I did this.
Okay.
Ella,
Yep. Has 6 pieces.
then I made one of these hexagon.
Okay. Right. Why did you do that again? Because you needed to remove that, what you told me, right? That you need to remove. Gotcha. So show me how you removed it and subtract.
I removed it. I did a hexagon like that, and then I took away 2, and took away 2, so we did 2 and 4. So that's 1.
Okay. So you see what she did? She made this one off to the side. Then she said she took away 2 and she took away 3. I want to ask you a question. How many holes were there to start with? 6. If I have, there's my 6, and then you made another one. These were hard to, let me help you flip these around so they look like a hexagon. How many holes do I have now?
7.
7, right? So how many holes do I need to have?
6.
What could we do here to get just 6 holes, but still use your fourths? What can we do?
You take away 3.
Okay, but if we need 6 holes, how could we have 6 holes? If I take away 3, I still have 6 and a 4.
You take it away.
Do what?
You took the whole thing away.
Yeah, so I want to take the whole thing away, but I need these. So is there something else I could take away?
One of the whole.
Ah, so if I took that away, now do I have 6?
Yeah.
Ah, so when you guys were doing it, you had added another hole. We want to be sure that on that regrouping, we can't just add another hole. We have to think about fair trading that out. So now you can take away your 2 and 3 fourths. So let's see what you got this time. 2 and your 3 fourths. 3. So we had a little different answer there because when that regrouping, that'll get us, right? If we don't watch about taking that one off. Here's what I'm wondering. I'm wondering if you can show, oh, I thought my alarm was going off. If you could show me what you just did here in an equation. Remember our success criteria, so you did to model it and write an equation. So I want y'all to think about what's the equation that matches what you just did with the whole regrouping of the whole. That was excellent thinking. But what does the equation look like for that? Can y'all work on that and I'll come check on you later? All right.
All right, what's happening up here? We're walking about the model.
Y'all can all talk. Okay, so let's look at all of your models here. Can y'all talk to me about why you chose to draw 6 rectangles? Oh, so these rectangles represent what? 6 holes. So talk to me about why you have them cut into 6 pieces.
The number 6.
Okay, so when we're thinking about fractions, what part of a fraction tells us how many pieces are in the whole? What part of the fraction tells you how many pieces are in the whole? The denominator. So what's the denominator? 4. So if we had a pizza and we wanted to cut it into 4ths, how many pieces would that pizza need to be cut? So if you just told me that the denominator tells you how many pieces are in the whole, yes. So if I said I want this pizza cut into 4, how many pieces would you cut? 4. So look at your pizza. Is your pizza showing 4ths or is your pizza showing something? Oh, it's showing 6 because it's in 6 pieces. I'm wondering if you could shift your model. I like your thinking. You have your 6 holes. I like how you're removing the 2 3/4. But let's think about our model and rework our model to only have 4 pieces in each hole, and let's see what happens there, okay? And then I want you to work on an equation that will match. All right? Okay. All right. You guys come up with up here in the front. You're drawing a model. Tell me about your model.
I don't know.
Oh, so what do you mean you didn't have enough? Why do you think you didn't have enough? What do you think? Okay, can you guys take a look at this model here? Are you Mason? Hi, Mason. My son's Mason. I like that. All right, so let's look at Mason's model. Do you see what he has here? Why do you think he is choosing to divide those into 4 pieces? What do you think? What in the problem made him think he needed 4 pieces?
Because of the
2 3/4. So, and you're telling me that 4 in the denominator told you you needed 4 pieces, right? So he has, what do you think these represent? What does this represent? 1 whole what? From our problem. 1 whole pizza? Okay. Sorry, it's hard to hear with the mask on. 1 whole pizza. So how many pizzas do we have altogether? 6 originally. So he has 3. What would you tell him he might need to do? Do 3 more, right? But then what are we going to do to find out how many were left? Or how many were eaten? We know how many were left. We're going to subtract. So we're going to need to remove that. So can you guys work on the model together here to show how you could remove and subtract that 2 3/4? And I'll come back and check on you in a minute. And don't forget that you need to work on an equation that matches that, okay? All right. Did you guys get that second number line for me? Let's talk about it. So did you shift both of the numbers? Remember our number sense routine, how both of the numbers went back to 1? So let's talk about this. What did you decide to do here? Oh, so what did you start with? Started with 6, and then you subtracted what? 1. And then okay. Two and 3/4. Okay. And so I'm wondering, why did you choose to take off the 1 and the 2 and the 1/4? Why did you choose to take off these pieces? What was your goal? What were you trying to get to? Okay, so you had put both of those numbers on a number line, 2 3/4 and 6. And so you were trying to hop from one to the other. Is that what you were thinking? I like that thought process. I'm wondering about your number line here. Look where 6 is on this number line, where 6 is on this number line. You notice something? Where do you think 6 should be on your number line? Probably at the end, right? Don't worry, Miss Lovis did this before too. I started at the big number and I went the wrong direction, but that's okay. You still showed your thinking beautifully. So you guys have 2 beautiful models here. I love your models. What I'm wondering though is if we could do that third model, another line where you could show where you start at 6 and you at 2 3/4 like y'all did, could you move them both one step? And what would that one step be? Talk to your partner and see if y'all could think of another line to draw back. Your lines are beautiful. I love them. And I'm wondering, could you take them and move them one step? And how big would that step be? Y'all talk about that. I'll be back. Did y'all come up with your answer over here? Yeah. So you did your 6. I love this equation. Tell me, so you, when I was over here before, you had removed the 2 and showed me 4. And then you did the 4 was left, and then you took off the leftover 3/4 to show your 3 1/4. I love this equation. So talk to me about your number line. You were trying to work on a number line, it looks like, because I had challenged you. Oh, look at this. Yeah, it's kind of, it makes your brain hurt. Oh, we got about 1 more minute. We're going to share some solutions, okay?
I was gonna go hop on the mark right now.
Yeah. So he started at 6, and he is, what does this say? 3 1/4, right? So why do you think he did this removing here? He removed, how much did he remove to start with? He removed 2 3/4?
Yeah.
But where's the 2? Why did he remove 2 first and not 3/4?
So,
Oh, right. But why would it would confuse me because this number is a what kind of number when I remove it and I stop at a whole number like that? What do we call those? What do we call those
that's
kinds
a
of numbers?
whole,
Yeah,
wait, that's not a whole?
right. It's not as friendly as,
Yeah.
remember those friendly numbers that we talk about with 10? This whole number is a friendly number. So then when he went back 3 more 4s, that made it a little easier to think about. So when I want you to keep thinking before I get up to the screen to show some of our solutions, how could you have taken this number and this number, the 2 3/4? How could you have shown both of those on a line and then move them both? Could you have done that? Talk about that, and we'll talk in a minute as a whole. Oh, you guys were working on your line. Look at that. What is happening here? How much did he take off from his 6?
He took 1/4.
Why?
Because, he had to start right over here,
Uh-huh.
and then he added 3/4. His
Uh-huh.
answer wouldn't be 6, but it would be 5, 3/4.
I got you. So did he do what the number center team person did and move it over? But the difference was the number center team person moved it 1 whole. He moved it 1 1.
1/4.
4. So what did that cause you to not have to do? High five, elbow bumps, all the things. I'm taking this with me. Can I take this with me? Awesome. Thank you. All right. So let's come back together. And we are going to share some solutions. Can I just say that